Welcome to the Center for Philosophy of Science annual lecture series, the first one of the winter season, as you can tell if you go outside. I'm Sandra Mitchell. I'm standing in for Edward Mashery, the director of the center, who couldn't be here tonight, but that's lucky for me since I get to introduce our speaker tonight, Kevin Zollman, who traveled a very far way distance to join us tonight, all the way from the philosophy department at Carnegie Mellon University. But before he was at CMU, Kevin received his PhD from UC Irvine, where I first met him and learned he knew the best cheap Mexican food that you could find nearby. Thank you for that. And I wanted to tell you a few things about Kevin before his talk begins. And there's many parts to Kevin Zollman. He spends most of his time deploying and investigating the use of game theory and other mathematical models in the explanation of social behavior, like the evolution of language or social norms or ethics and scientific practice, which we're going to hear about today. His strategy lets him consider, for example, how human behavior and animal behavior are alike and different, but framing questions in terms of signaling and crossing the disciplines of evolutionary biology, linguistics, social theory, and of course philosophy. He also works on cooperation in the evolution of social behavior and what the impacts are that different social practices have on scientific success or failure. Kevin works on collaboration in science, and he knows about it firsthand because he's a very generous collaborator who writes papers with linguists, ethicists, other philosophers, with graduate students and colleagues, and I think that's something to celebrate in his work. But in addition to his academic work, I deeply admired Kevin's intellectual engagement with the public. Recently, an op-ed piece he and Danny Wenner wrote for the New York Times titled "How to End International Tax Competition" was awarded the 2018 APA op-ed contest. Won it, I guess. Aren't awarded a contest. Okay, it's a contest, that's weird. Okay, he won it though, they won it with that. And it's a really interesting article, I encourage you to read it. It's about competition and cooperation and what that means for various political strategies that seem to be taken very widely these days. I tell you about it. In it, they look at the strategy of lowering corporate taxes to attract corporations to move from one country to another. And they look at it through the lens of game theoretic collective action problems, which I think is a really interesting way to do it. He's also a philosopher whose work can help solve real problems. He wrote a book with, this is where I push this, with Paul Rayburn called The Game Theorist's Guide to Parenting, right? And I just want to read you one quote from a Wall Street Journal review of it that said, unlike most parenting books, this one is based on actual research into how humans behave. It should increase the odds that there will be less whining for all involved, right? Okay, that's a real compliment for a philosopher, I think. However, one might suggest that the lessons for human children might not clearly translate to our non-human companions, as Kevin and Corinne's dog Lubna seems to indicate in this film. So even though he's interested in how humans and other species, might be subject to the same things, it's not clear that it's going to work with Lubna. And with that, let me invite you to Kevin's talk on science, progress, and the desire for credit.
Thank you all for coming. Thank you very much, Sandy, for the introduction. It's graduate admissions season, and that gave me a moment to reflect on my own history. And as somebody who was not admitted to either Carnegie Mellon or Pitt's PhD program, it really feels good to be a professor at Carnegie Mellon giving a talk at Pitt. So thank you very much for that. Comes around. So,
We're sorry.
No. Carnegie Mellon. Didn't let me in either. So today I wanted to kind of give a talk that is sort of a status report so to speak, about a large-scale project that has many different facets to it, but which I think is really interesting philosophically, although it's about a problem that has, certainly in the long history of philosophy of science, been largely ignored, although in the recent philosophy of science has begun to make a more wide impact. And so I wanted to kind of talk to you about what is known and what isn't known about the project now, but to also sort of raise some questions and point out some areas where we don't know that much and where we'd like to know more in the hopes of maybe recruiting some help, which I so desperately need. But I'm going to start out with a statement so obvious it will surprise no one, as any good philosophy talk should. Scientists care about getting credit for their discoveries. This is just a fact about scientists, and it's not a fact about modern science, although a lot of people sometimes talk about this as this is something, a modern phenomenon. It's a very old phenomenon. Leibniz and Newton fought about who invented the calculus. A lot of the scientists from centuries ago would write their discoveries down in code or put them in sealed envelopes and deliver them to friends or professional societies in an attempt to make sure that should they get scooped, they could prove that they had the idea first. So this idea that scientists care about getting credit is almost as old as science itself. And is very intimately tied with the notion of science. Now, of course, I can't just say something like this. We have to ask, so what? What's the point of this, and what does that observation get us? It's sort of surprising, perhaps, or maybe, I don't know, not so surprising, that, for the first 20 to 50 years or so of philosophy of science, this was about as far as this conversation got in the philosophical literature. And then starting with the shift that happened around the time of Feyerabend and Kuhn, it became more prominent, although still occupies a relatively, for a long time occupied a relatively small niche in philosophy of science. I think that's changing and growing, and so I want to talk a little bit about this issue, and really to answer this question, so what? That scientists care about credit. I don't, knowing, since I know you all pretty well, or at least everybody, I think most of the folks in this room are already relatively convinced that this is an important philosophical problem, but I want to quickly, relatively quickly, go through why it is I think that this is an important issue for philosophy, just to say what it is that I hope, mostly to set the stage for what it is I hope we can learn in investigating this question, and connect it to a couple of philosophical problems that we all know. Philosophy of science, as sort of everyone in the room already knows, philosophy of science sort of has broadly two dimensions to it. It has a descriptive and a normative dimension. Obviously, some people sign on for one or the other dimension and not the other. But the descriptive dimension is a prominent one in philosophy, where the idea is that we're trying to sort of provide a description of what scientists are doing when they conduct science, right? So that's a lot of what philosophy of science does. So one might say that philosophy of science shouldn't care about whether or not scientists care about credit for reasons like this, right? So this is maybe something you probably wouldn't hear today, but you might have heard 30 or 40 years ago. And actually, I shouldn't even say you wouldn't hear it today, because I've heard it not that long ago, but I think it's probably rescinding in terms of its popularity in the philosophy of science community. So something like this, right? Philosophers describe relations between cognitive objects like evidence, theory, experiment, explanations, etc. Those cognitive objects, at least as they're instantiated in the heads of scientists, don't depend on the desire for credit. Therefore, philosophy of science need not worry about the desire for credit. So this, not that anybody's published this argument, but this is something that you sort of get, it's in the air, people will tell you over a beer or something like that. Probably you already immediately see what's wrong with this argument, which is the highlighted second premise, right? Of course, in fact, in scientists' heads, these relations do depend on scientists' desire for credit. That is, the theories that they believe will sometimes be influenced by whether it's their theory or someone else's theory, because they'll not want to give credit to a rival. The evidence that, whether or not they regard evidence as evidence for a theory can be influenced in the same way. What evidence they choose to collect, what experiments they regard as veridical or useful, will all depend on their desire for credit. So as a descriptive matter, scientists do, in fact, decide about the relations between these cognitive objects on the basis of credit. Maybe they wish they didn't, or they're ashamed that they do, or they hide the fact that they do, but they're humans, and so, of course, these things are going to influence them. Now, on the normative side, you might imagine a sort of similar or parallel argument that you might get on the normative side. Something like, well, philosophers are supposed to develop normative theories of scientific method that might be cashed out in terms of relation between those cognitive objects, or might be in some other way entirely. And the normatively ideal scientist would not be affected by the desire for credit, and therefore philosophy of science need not worry about this. There's also a kind of middle ground, between descriptive and normative, something like, explication, Carnothian explication is what it sometimes gets called as, or reflective equilibrium, conceptual analysis, those sorts of things. And you might imagine something along those lines as well. But I think that there are two problems with this kind of argument as an argument against caring about the desire for credit from a philosophical standpoint. The first is, in a certain sense, it begs the question, because it's not obvious, pre-theoretically, that normatively ideal scientists would not be affected by the desire for credit. We need to investigate the consequences of the desire for credit before we can say that normatively ideal scientists would not be affected by the desire for credit. So this, as an argument against philosophers caring about the desire for credit, begs the question, first of all. The second concern, and this is, I think, an old thread that runs through philosophy of science for a while, although it's always sort of been a minority view for a long time, is that there is an important distinction to be drawn between normatively ideal behavior at the individual level and normatively ideal behavior at the collective or group level. So that is, it is entirely possible that normatively ideal individual scientists might not care about credit, but a normatively ideal collection of scientists do. Right? That is, that we could have an ideal group which is made up of non-ideal individuals. Right? And this idea is familiar to a lot of us in the economic or decision context. Oftentimes, the prisoner's dilemma or voting paradoxes are sometimes described in this way. The idea is that you might have rational individuals who make up irrational groups or vice versa. But in the scientific case, this idea has been brought up several times. So there's David Hall, who famously, I didn't put it up here, but he has this sort of beautiful quote, not really an argument, but it's a nice quote, in Science as a Process about how this might happen. Miriam Zollman has this paper in 1992, and then later her book, Social Empiricism, where she discusses this possibility about how normatively ideal groups may be made up of normatively non-ideal individuals. And then in the more formal epistemology, mathematical framework, I have a paper with Connor Mayo Wilson, a former student of ours, and David Danks, my colleague, where we show using a particular formal framework that in fact this is actual, that it is at least possible in the sense of there exist normatively ideal groups that are made up of non-ideal individuals and vice versa, that there are normally ideal individuals who make up non-ideal groups. So even if it's the case, even if you sort of feel for some reason or another committed to the idea that individual scientific method, normatively ideal scientist doesn't care about credit, that actually doesn't mean that science as a community process should be made up of individuals who don't care about credit, because it might be that the normatively ideal group is made up of normatively non-ideal individuals. Okay, so hopefully I've convinced you of the thing you were already convinced by, that it's important for us to care about credit, and that it's important for us to care about the desire for credit. Now, once we decide we need to care about this, there's sort of two levels of questions that we can ask. The first is, what are the consequences of scientists caring about credit? So that is, does that make science better or worse? Does it make it more or less progressive or more or less normatively ideal according to a standard? And of course, to answer that question, we need to have the alternative in mind, right? It's not care about credit or don't. It's care about credit or care about something else, right? Of course, scientists don't only care about credit. I'm not so naive as to think that. But the idea would be, well, is it just that they care about credit versus caring about truth or something like that? Right? So there are a lot of different options. Natural thing is something like truth or good theories, where good theories might be cashed out in something other than truth. But even that by itself is already a little ambiguous, because I could care about truth because I care about the truths that we produce as a community, making no distinction between the truths that you discover and the truths that I discover. Or I might care about truth, but in a more self-interested way, right? I might strictly care about only the true theories that I produce. Even if I don't get credit for them, I might nonetheless want to put some special emphasis on what I discover or what I figure out. But of course, that's not the only alternative, right? They could care about friendship or enmity or getting invited to annual lecture series or fancy cars or something like that, right? So just credit, always need to specify an alternative. I'm mostly, in this talk, going to think specifically about the very generic, broad, truths-produced alternative. That is, a sort of care, what pre-theoretically we might have thought as the normatively ideal science, who just cares that we learn what the world is like, whether I discovered it or someone else did. As I'm going to talk about this, I'm going to point out a few times that there are subtle differences in the answers that we get, depending on how we specify the alternatives. Okay, so that's the top level question. What are the consequences of scientists caring about credit? Is it good or bad from a normative perspective? What consequences does it have from a descriptive perspective? But then there's a sort of second level or slightly lower level question, which is also important and interesting, which is the question of, well, what are the consequences of the particular social norms of the way that we allocate credit? Right? It's not just that I care about getting credit, but there are these rich, complicated social norms that surround who gets credit for what discovery. The most famous one, the one that gets discussed most often, is named by the sociologist Merton as the priority rule. This is the idea that the first discoverer of something deserves most of the credit. Now, we all probably know that it's not always actually what happens. Sometimes the second or the third discoverer, the first person to steal it from somebody else or whatever, gets it. But the idea is that this is the kind of normative ideal. But of course, that's only one social norm about who gets credit. There are lots of other very complicated social norms about who gets to publish, in what venues, and how much credit they get, about publication order, about who gets cited and for what reasons, about who gets promoted, about who gets awards. There are all these complex and rich social norms that vary from science to science and that have lots of different aspects to them. And there are lots of philosophers who are working on all of these different issues. So Hyacinth, for instance, who's here, is working on social norms surrounding how we give out credit in co-authored publications and how we think about those and how maybe we ought to think about those. In this talk, I'm going to mostly just focus on the priority rule. I'm going to focus on that for a couple of reasons. First, it's the one that's been most studied, so that's the kind of thing that we have the richest concept of. And secondly, I think that the priority rule is sort of inextricably tied to the notion of credit. That is, I think that, that science could not exist, at least there couldn't be a notion of scientific credit if we didn't have something like the priority rule. And let me give you the quick cocktail napkin version of this argument. It trades on a really fundamental economic result about what are called principal-agent problems. The idea here is that in science there are two things which are kind of unobservable from a social perspective. That is, it's very difficult for the community of scientists to observe how hard an individual scientist is working. So this is, in economic terminology, effort is unobservable. That is, I don't know whether you've been in your lab all night checking Twitter or you've been in your lab all night working hard to try and make a scientific discovery. So there's no way that I can reward your effort. I can only reward the output. I can only see, have you made a discovery, yes or no. And the second is that good plagiarism, not the kind of dumb plagiarism that we sometimes see our desperate undergraduates doing, but smart plagiarism where you really make it look like it was your own idea, is also undetectable. That is, if Sandy publishes a really important and insightful paper, and then I come along 2 weeks later and say, oh, it turns out I was working on the same idea, and she just beat me by 2 weeks. There's no way that you as a scientific community can distinguish between me actually having been working on it for a really long time and had the same idea, or me just reading Sandy's paper and really creatively copying all the ideas down in my own vernacular and claiming to have been working on it the whole time. Right? And so my argument is that because of these two features, there's really no way that we can give out credit in science except via the priority rule. And so as a result, if we want scientists to care about credit, we kind of have to use the priority. Okay, so that's the quick cocktail napkin version of that argument. All right, so let me stop, before I get to the real nitty-gritty, let me stop and just say one thing about methodology. That is, how should we approach this problem? Because these questions are inextricably counterfactual, hence the cute cartoon up here, we have to ask questions about these alternatives. What would science look like if scientists didn't care about credit, if they cared only about truth, or if they cared about friendship, or whatever our alternative is. And because credit and the desire for credit has such a long history in science, it's not as though we have episodes in the history of science where scientists didn't care about credit and we could make the comparison. Nor, because science is so big and expensive, could we imagine doing an experiment where we create a scientific community that doesn't care about credit and we see how they do. So we're having to ask counterfactual questions, but ones which we don't have any sort of direct empirical evidence for. So as a result, we're going to have to engage in some kind of method of counterfactual modeling. Now that might be mathematical modeling, which is my preferred way of approaching it. It might be more qualitative modeling, where we sort of imagine how a case would go if the principals in the case didn't care about credit. But whatever we're doing, we're going to have to be running some kind of model, either qualitative or quantitative model, about how people are doing. And in the stuff that I'm going to talk about, you'll see examples of both qualitative and quantitative modeling. But this is one of those cases where, while empirical evidence would be, direct empirical evidence would be wonderful, we don't really have it, and I don't think we're going to be likely to get very much of it. Okay, so now I'm going to talk about what we know, the state of the field now. So that is, okay, so scientists care about credit. When is that good? When is that bad? When does that help lead to good scientific outcomes? That is, leading to better theories, more progressive science, or something along those lines. And when does it lead to bad or negative or harmful scientific theories? And so I'm going to kind of go through a list. I got 3 lists here: the good, the bad, and the hard to say. Right? And that's what we're going to go through. So we're going to go through first the good. Batman's good, by the way. That's why he's there. Public goods. This is the first, I think maybe the oldest observation about the interesting thing about the priority rule in particular, and caring about credit in general. That is, it's a long observation that science, knowledge in general, science in particular, is a public good as a term of art in economics. So what does that mean? Well, when economists talk about public goods, they mean it's 2 things. It's non-rivalrous and non-excludable. Non-rivalrous means when I consume it, that doesn't prevent you from consuming it. Right? So if I eat a donut that's, say, sitting in front of us, then you can't eat that same donut. So that's rivalrous. But knowledge is not like that. If I know something, that doesn't mean you can't know it. Right? You can also know it. So knowledge is non-rivalrous. It's not excludable. That means it's either impossible or very difficult to prevent others from getting it. So if there's a donut up here and I want to prevent you from getting it, I can erect a wall that prevents you from getting to the donut, and so then I can exclude your access to the donut. But it's much harder to build a wall with knowledge. That is, once you know what the knowledge is, you already have it. Right? So you can't, so to speak, know of it without being able to have it, and there's no way that I can prevent you from transmitting it to somebody else, because the transmission costs are effectively 0 with knowledge. So knowledge has this feature of being a public good. It turns out, as far as I can tell, the first person to really acknowledge this fact is Thomas Jefferson, of all people, when he was writing letters back and forth about how intellectual property law should be structured in the burgeoning United States. The fact that, what does credit have to do with this? Well, the observation of a number of different scholars has been that credit has this way of turning the public good into a private good. That is, while I can't stop you from consuming the knowledge, and while your consumption of the knowledge doesn't affect my consumption of the knowledge, I can prevent you from getting credit. That is, if I get credit, you can't have it. That's rivalry. And if I have credit, I get to control who else gets it. I can give it to you. I can say, no, that idea was really John's. Right? I can give the credit away, but I can prevent John from taking it. So it's both rivalrous and excludable. So this observation, I think, was come to independently by groups of economists, Dasgupta and David in 1994, and Paula Stefan in 1996. I'm violating the priority rule by not just giving it to Dasgupta and David, but my understanding is that this was multiple discovery. And then also something which I explore a little bit in a more recent paper in Journal of Philosophy. So the idea here is that one of the virtues, and perhaps the central virtue of the desire for credit, is that it encourages the creation of public goods. Markets are not good at creating public goods. That's something we all know by driving around Pittsburgh. And so instead, transforming it into a private good is one, not the only, but one way that we can encourage creation of public goods. So this is an observation about the value of caring about credit and the value of priority rule in particular as a way for allocating credit. The second observation about the desire for credit is also a really old one and kind of an interesting one. One thing that the history of science has revealed, which is sort of initially surprising to philosophers, but when on reflection maybe not so surprising, is that there are lots of theories, true theories, good theories, that initially didn't look so good and needed somebody to sort of cling to them like grim death for a few years for eventually the evidence to come out that shows that they were effective. So Miriam Zollman uses the example of continental drift in her paper in 1992. There are other examples. I've talked about peptic ulcer disease in one of my papers. There are lots and lots and lots of examples in the history of science where initially a theory doesn't seem very well supported by the evidence, and then later on, after somebody sort of tenaciously refuses to let it go, evidence comes around and we come to believe it. So this is examples where, in particular, people tend to cling to those theories because they're it's my theory, right? It's my theory. I'm going to, even though the evidence is against it, I've said that I've staked my professional career on it, and so as a result, we're just going to see how it ends up. And even Popper has suggested that this is sort of a good feature of the desire for credit, that people stick to theories even though, in his language, they appear to be falsified or they appear to not be empirically adequate or the evidence seems to speak against them. So this is another feature where, specifically against something like the more, I only care about truth and so I'm happy to give up a theory if it looks unsupported, it looks like the desire for credit is something that might actually be beneficial to science because it encourages people to sort of cling to theories, look for evidence where they otherwise might not look for evidence, out of the desire to make sure that, well, it's my theory, so it's got to be true or something. The last major advantage of the credit economy that's been brought up by, it sort of shows up in a bunch of different places, perhaps most clearly by two economists, Boettke and O'Donnell, is that by caring about credit, that gives us that is society, not necessarily scientists, a society, a kind of lever on which they can influence the direction of science relatively easily. So the idea is if we really need scientists to work on a particular problem that's of social interest, like we need them to work on, to come up with a vaccine for the Zika virus or whatever, then if we can just find a way to make sure that a lot of credit will be given to whoever is going to discover that, that lever allows us to reorient a bunch of scientific effort all at once, right? All we need to do is, as a professional organization, offer a big prize or a lectureship or a big promotion or a grant or whatever on the basis of those things, and then naturally a huge amount of labor gets reoriented. If scientists only cared about truth or something like that, then in order to reorient a large amount of labor, we'd have to go around and convince each and every scientist, hey, you really ought to care about this, here's why, or something like that. And so the idea is that the desire for credit gives us this thing. If we can just control how credit is assigned, we have this lever that allows us to reorient science so that scientists start studying problems that are of social interest. Of course, it also has a negative side, which is who's got their hand on that lever, of course, right? And there are great examples from the history of science of of societies where things go really wrong because the wrong person gets their hand on that lever. But, I don't know, this is one of those things where at least some folks have suggested that this is an important feature of science. Okay, so that was the good. Now the bad. There's the joker. The bad, there's a lot of bad also about the desire for credit. Some of it is stuff that's already going to be familiar to you, stuff that you've already thought of or experienced yourself in dealing with colleagues who seem to care about credit more than you might wish they did. The first and I think oldest observation about this comes from a surprising source, Adam Smith, who in the theory of moral sentiments suggests that credit is a bad thing to care about because it increases the degree to which people polarize, they form cliques and in-groups and out-groups. Now, it's a great passage to read. It's too long, I didn't want to put it up on the screen, but it's hilarious because Adam Smith describes about how scientists never care about credit, and all the scientists that he's aware of couldn't possibly have cared about credit. I guess he didn't know about Newton or something, I don't, but he compares them to literary folks who he thinks do care about credit, and says that the problem with the literary folks, and not with the scientists, sort of comical, is that the literary folks divide themselves into cabals and only reward others who are in their cabals. It's a perfectly valid concern. It's just also true about science, and was true about science at his time as well. A more recent and mathematical investigation of this problem is due to Akerlof and well, let's see now, Edward needs to be here. My French pronunciation is terrible. That name. Where they look at the consequences of people having this desire to preferentially interact with, cite, and hire, in particular, people who work on similar things that they do. And what they show is that even with a very small preference towards others who are in your paradigm, so to speak, what they call false paradigms are going to be, can easily take over even. And so that this desire for homophily is a sort of technical term, this desire to reward those who are like you or research things that are similar to you can have this really strong negative consequence. Another important point, also a very old one, doesn't have so much to do with the internal considerations about the degree to which science progresses, but rather external considerations about how science and society interact. So philosopher and sociologist W.E.B. Du Bois talks about this in a number of different contexts, where he says it's very important that the public at least perceive scientists as being sort of dispassionate communicators and investigators of truth, because if not, they're going to end up not believing scientists, right? Now, Du Bois was writing this and during Reconstruction, at a time when there was a lot of interest among scientists in researching issues about race and race relations in the United States, and that there were a lot of people, many of them in the South, who had pre-committed reasons to disbelieve certain types of scientific conclusions. And Du Bois was really worried that if it looked as though the sociologists of the time had political commitments that they were trying to support with science, that those who already were destined to want to disagree would disagree. Now this is Reconstruction, it's over 100 years ago, but it rings true today, right? I mean, this is climate change, this is evolution, this is research in economics. There's lots of stuff which is happening today. There are people that disagree with science, and they disagree with it by pointing to political commitments of the scientists. So this is not an old problem. Du Bois never made this point in like one place. He didn't ever write an article about this, but rather it's sort of something that he brings up throughout a lot of his writings. If you're interested in learning more, I would really recommend Liam Kofi-Bright's paper, where he sort of puts it all together in a really nice and clear way. Many of you remember Liam. He's sadly left us to go to LSE, happily for him, but sadly for the rest of us that still haven't heard Pittsburgh. Okay, so that's another thing. Another, and this is the kind of obvious thing that always gets brought up both in the media and kind of public discussions about science, is that when scientists care about credit, it increases their incentive to engage in sloppy or somewhat fraudulent research. That is, it encourages scientists to sort of rush results out the door, so to speak. Right? So another now former Pittsburgher, Remco Haysen, uses the example of cold fusion, where it's pretty clear that Ponzi and Fleischmann made their announcement ahead of when they probably would have ordinarily wanted to, because they were afraid of being scooped by another researcher, and as a result announced what was not a real discovery. And so this is an example where the desire for credit or the worry about credit may have hastened or may have resulted in an error that might have otherwise been caught. Now, of course, the historical case is hard because we don't know if it would have been caught if they hadn't cared about credit, or if it was just a mistake that they were inevitably going to make. Using a very elegant mathematical model, Remco demonstrates how basically anytime scientists care about credit, this is inevitable. That is, that scientists are going to engage in a kind of rushing and tolerance of error that's higher than we would ordinarily want. Of course, there's always error in science, but Remco has a really nice paper where he sort of shows, in very simply and very generally, that basically all the time scientists are going to try and rush things out the door. Paper that just came out in the most recent issue of Journal of Philosophy. Another way in which this might be harmful to the scientific enterprise, and this is actually the one that's probably been investigated the most, is the degree to which the desire for credit reduces something that now goes by this term cognitive diversity. And what cognitive diversity means is something like having a collection of scientists which distribute their labor, their effort, over many different theories or methods or approaches in ways that are beneficial from the group perspective. That is, it's pretty, in general, we kind of recognize that in science nowadays, it's very valuable to have scientists distribute over many different approaches because antecedently we don't know which approach is going to succeed. We don't know which theory is true, we don't know which methods are better, and so by having scientists work on different methods, we ensure that at least, we maximize our chance that at least one of the methods succeeds at what we're doing. There are a number of ways in which it's been demonstrated that the desire for credit can harm cognitive diversity. The first one is in particular in situations where you have certain methods or theories which are high risk, and that is low probability of success theories. So that is, if there's one approach which is very likely to succeed, and another approach which is not very likely to succeed but might, scientists who desire credit will over-allocate their efforts to the likely to succeed and against the unlikely to succeed. I'm going to come back to this in a moment. I've got a little asterisk there, but let me go through the other things and then I'll come back to it. There's a caveat that I need to add to that. There's another phenomena which was, I think, first identified by Carl Bergstrom, Foster, and Yang Bo-sung in this paper in 2016, which as far as I'm aware isn't published yet, but you can get on the archive. That it can actually be that especially big scientific labs can discourage competition. So the phenomena that they're interested in is something like you have an outbreak of a disease, like say Zika, and you know that we need to discover either a cure or a vaccine or whatever. If a big lab that has lots of resources and lots of money can publicly show that they're shifting all of their resources into that research, into finding a vaccine or whatever, then the fact that the big lab is there will discourage small labs from also working on it. Because the idea is the big lab's probably gonna, if there's a vaccine to be discovered, the big lab's gonna find it before the small lab. And what they show is that in a plausible number of settings, that can actually be bad from the community's perspective. It can actually reduce the probability that the community finds a vaccine because each individual small lab doesn't enter into the race to try and find a vaccine for Zika, but from a community perspective, we'd like there to be a few more labs, not just one big lab, but rather a few more, right? And that's because of diversity sorts of concerns. So they show this again in a kind of mathematical model where all of this can be made really precise, but I think the mathematical model is really elegant and clear, and I think is a real serious concern in a certain domain of science. The third way in which it can reduce diversity is a little bit more complicated to explain, and mathematical model is a little less penetrable. Comes from first a paper by Dasgupta and Maskin, and then later, this is a slight generalization from just Dasgupta in 1990. The idea is that if you and I are engaging in a race, and we have many different ways of doing the race. So the idea is, think, I don't know, Jules Verne's, we're racing around the world, right? And then we can decide, like, what's going to be the way that we race around the world? How are we going to get around the world? What path are we going to follow? Well, if there's one path that looks like it's really the right path, the most likely to succeed, and then the idea is if we both take that path, then it'll just be a flip of a coin, which of us, gets across the line first. It's just, who stumbles first or whatever. It might be that we both decide that our best chance is to take the same path and just see who stumbles first, than to pursue another path which might go faster but probably won't. Right? So that is, we actually have an incentive to correlate our success and failures to one another and not distribute our efforts across the different possibilities. So that's the idea, and that you can show this using a kind of framework that comes from something called tournament theory in economics, where you can show that in priority races, people are going to over-correlate their methods with one another. That is, if we're both trying to discover the structure of DNA or the cure for Zika or whatever, we're going to actually, and we only care about credit, we're likely to adopt methodologies that are too similar to one another from a social perspective. Diversity is hampered in this way. The last way is one that Liam, Kofi Bright, and I are investigating in a paper that's in preparation. It was part of it was part of his dissertation. We're doing a little bit more with it, is the ways in which credit and the way that credit is allocated can discourage people from actually pursuing the projects that they're really good at. So the idea is, you might imagine that I'm really good at, say, mathematical modeling and philosophy. I'll entertain myself and imagine that that's true. But if I come to philosophy at a time when mathematical modeling is very unpopular, I might opt to instead do a different type of research for which I'm less apt, right? But because I'm worried about there being no one to give me credit for my discoveries using mathematical methods, I might decide to do something which I'm worse at because I'm worried about credit. So that is, encouraging people to care about credit might actually encourage them to, in Liam's terminology, hide their talents under a bushel. Right? That is, to pursue something that they're not as good at. Okay, I promised you an asterisk, so let me go back to that. The degree to which this is in fact true depends on exactly how we define the alternative motivation. So I think there's a right way to do it, and that's what I do here in this paper, but there is a real dialogue here between the way that Kitcher does it, the way that Strevens does it, and the way that I do it, and the conclusions that you get are somewhat different. So depending on how exactly we define what truth-motivated scientists will do, that first conclusion you can change that first conclusion. But since I'm talking here and they're not, I'm going to say I'm right. That's philosophy after all, right? That's what I'm supposed to do. All right, last thing, this is new work that I just presented at PSA, so sorry for those of you that have heard this little bit already. One of the things that credit, and in particular the connection between credit and real resources like dollars and lab space and postdocs and PhD students does, is it creates the possibility that people can sort of create self-perpetuating fraudulent niches for themselves, or what I've called the scientific Ponzi scheme. So there's Brian Wansink, who you may have heard of recently. He's a soon-to-be former food marketing researcher at Cornell. And he's been caught up in a really substantial case of fraud. We don't even really know all the details because, at least as far as I'm aware, Cornell hasn't released their internal investigation. But it's very clear that it's been going on for a long time and really widespread. And it seems like, at least looking at what documentation we have, what Wansink was able to do was do some work that was either fraudulent or sloppy, it's a little hard to tell what, but made a big splash. Because you know of his research, even if you don't know him by name. You've read the New York Times stories about where food is on the shelf determines how much you buy, or how much is on your plate determines how much you eat, or all of these different things. You've heard of it. And he did some initial things that got a lot of press, got him an enormous amount of funding. And then, as people became skeptical of his early work, he had all this funding, so he had new work. And so people were like, well, we're sort of skeptical of his early work. There's some problems, it's not replicating quite right, but he's got all this new stuff. And then all that new stuff got him even more funding. And then people got skeptical of that stuff, but then he had even new stuff. And so he just kept turning his new research into more funding. But each time people, after a while, got skeptical of it. That's why I'm saying it's sort of a one-person Ponzi scheme, right? One-person. And so I have a mathematical model of this phenomena, and what I try to show in that model is that this is a really difficult thing to avoid. That you really, the ways that you can disincentivize this are really, we would be uncomfortable with, because they involve things like really draconian punishments for good faith errors, or really radical changes in the normative way that we assign credit. So this might really be a kind of inevitable feature, or near to inevitable feature of credit. Okay, I promised you the good and the bad. This is the hard to say. This is the things that sort of are both good and bad depending on the circumstance. So the first one is actually really surprising. There are very smart people who said in print that the credit motive was bad because it encourages people to keep secret their results. The idea being that I ought to keep my results secret until I have the big discovery, because I don't want to help you to catch me. Right? I want to keep you away. So if I'm working on a big discovery, I should keep everything secret until I've got everything, and then I can publish that big, important paper in Science or Nature or whatever. And that's not completely wrong, but it actually depends on exactly the structure of how credit is assigned. That is, it depends on some subtleties that are a little bit surprising. So there are a couple of different people who investigated this. What I'm going to walk you through is the argument from Remco's paper, Communism and the Incentive to Share in Science. Similar conclusions in very slightly different contexts and of different levels of generality can also be found from Thomas Boyer, and then this paper by a group of researchers that kind of lie at the boundary between economics and computer science. So here's the idea. I'll give you the model in a nutshell. We've got some scientific problem that's really super simple. It's got 3 steps: step A, step B, step C. You can't do each step until you completed the one before it. So you can't solve B until you've solved A. You can't solve C until you've solved B. And we've got 3 scientists. You can tell because she's wearing glasses. That's how you know she's a scientist. And they're each trying to complete as many of these steps as possible. So we imagine they start working on this problem, and lo and behold, scientist number 3 manages to complete steps A and B right away. Scientist number 2 just completes step A. Poor scientist number 1 up there, she's not done anything. And then we can imagine like scientist 3, also maybe 2 if we want, is given this opportunity. Should I stop now and just write up A and B and publish that, or should I keep it secret and try and complete step C and then publish it all as one big unit? What's the consideration here? Well, if she publishes A and B now, she ensures that she gets credit for A and B. Because if she keeps it secret, maybe scientist 2 catches up to her, maybe even passes her, and then takes credit for everything. And scientist 3 gets scooped, right? On the other hand, if she does publish it, then that means scientist 1 up there, the one who's stuck left in the dust, can do steps A and B because she can read the paper, she can complete the results, and so now they've caught up, and so now scientist 3 has helped the other 2 scientists get closer to the goal of C. So Remco looks at a very simple mathematical model that has this structure. It doesn't have to have 3 steps, but they have to be linear in this respect, and asks this question about whether scientists should share. And what he shows is that it depends very particularly on, in a certain sense, the amount of credit that scientists get for the various parts. So if say each step is equally valuable, so I get, if the credit that I get for A is 1/2 of the credit that I get for A and B together, and the credit that I get for A and B together is 2/3 of the credit I get for A, B, and C together. So you can think of them as each being worth 1 unit of credit. If they're each worth 1 unit of credit, then then the rational scientist will always publish. As soon as she has anything that she can get published, she should publish it. Right? And similarly, if A is, this is more obvious, if A is worth more, right? The initial discovery is the big discovery, and then the later discoveries are less important, then obviously you should publish, right? I think that one's not so surprising. But if that's reversed, if it turns out that we've got a project like discovering the structure of DNA or discovering the vaccine for Zika, where all the credit is sort of heaped onto that last stage. The early stages are valuable, but not that valuable. But the person who discovers the structure of DNA really gets all the credit. Then, in that context, scientists should be secret. All right. So that's why I say this is one of these hard to say things. It depends really on the way that the problems are carved up and the way that we reward credit on the basis of how those problems are carved up. This paper, the Banerjee, Goel, and I'm not going to try, I'm sorry, it's going to be an embarrassment if I try. This paper proves a slightly weaker result, but in situations where the projects don't have to be linear in this way, where you can imagine sort of branching, where it's like there's B1 and B2 and they're substitutable for one, something like that. So you can look at these different papers and see sort of slightly different versions of a similar result. Okay, outright fraud. This is one that you might be surprised to see in the who knows case, because it seems like why would truth-motivated scientists ever have an incentive to commit fraud? Isn't fraud always an attempt to get credit for something that I didn't really discover? But it turns out that it's not quite so simple. So Liam Bright, in a different paper on fraud, has shown that there is a phenomena, and it's a plausible phenomena in science, where people might engage in what he calls noble lies. That is, they might have a conclusion that they already believe is the correct conclusion, And so might think, well, I have data that suggests against what I believe to be the true theory. I'm not going to share that. I'm not going to publish it, or maybe I'll even fudge the data to make it look like it does support the true theory, because I care about the truth, and I care about other people believing the truth, and so I want to convince them of the truth. Right? And so this is what he calls noble lies. And so this is a context where, even in the alternative, where people care only about truth, they might nonetheless engage in fraudulent behavior. Now, of course, this doesn't quantify. It may well be that people who care about credit engage in more fraudulent behavior than people who care about the truth. But the point is, caring about the truth is not insurance against fraudulent behavior. Right? There are circumstances. This is a sort of proof of concept. There are circumstances where that can come about. And of course it can be very bad, because I've got a picture of Colin Powell here for a reason. I think Colin Powell really thought we should invade Iraq, and it may well be that his claim that Iraq had weapons of mass destruction was a noble lie of this kind. But of course it might lead us to the wrong conclusion if the person who's engaging in the noble lie believes something that's false. All right, the last, or one of the last sort of hard to say things, I think this is the last hard to say thing, is the incentive to police and replicate. So I'll just go through this one briefly. I'm running a little short on time. There's this question about why replication crisis in psychology and other fields has brought forward this question of why don't we replicate more? And a lot of people have put this on the desire for credit. But this is not quite right. Because it's the desire for credit and also the way that we assign credit. That is, that we sort of undervalue replications, we undervalue engaging in trying to overturn other people's results. We undervalue maybe publishing negative results or something like that. And so that if we weighted those things differently, if we gave people lots of credit for failures to replicate, for instance, or lots of credit for publishing negative results, it may well be that we might replicate it at a more optimal level, or we might even replicate too much. And that's kind of the result that Justin Brunner shows in this paper in Episteme, and a point that Felipe Romero investigates from a more qualitative perspective is that it may well be that this isn't really completely connected to the desire for credit. That if we change the ways that we reward replication, we can keep scientists caring about credit and get the right amount of replication, or even potentially too much. So while oftentimes this is trotted out as, oh, it's so sad that scientists care about credit, that's why we have the replication crisis, I don't think that stands up to scrutiny. I think that these two papers, in particular Justin's, I think, shows that it's really more about the particular social norms that we use and not about the credit motive or the priority rule in particular. Okay, so I told you this was sort of a status report, so what's the status report? I mentioned at the very beginning that there are sort of two philosophy of science projects, the descriptive and the normative, and we can ask, how have we done on both of these descriptive and normative projects with respect to the desire for credit? I think we've made a lot of progress in the descriptive project. We've discovered a lot of causal relations. That is, we can say a lot of things about how the desire for credit affects various scientific outcomes. The desire to share, the desire to engage in fraud or sloppy research, the desire to produce research to begin with, et cetera, et cetera, et cetera. So we have now a richer understanding of the relationship between, on the one hand, the desire for credit, and on the other hand, progressive or valuable science. The normative project, we're left in a bit of a murky territory. That is, we've got some positives, we've got some negatives, we've got some it depends. But then if we want to ask the broad question, is it good that scientists care about credit? Does a normatively ideal scientific community care about credit? We can't answer that, because we don't know about the balance between these two different things. Some little tiny progress has been made. The paper that I mentioned in the Journal of Philosophy, I attempt to compare just two of those things. That is, the positive, the public goods problem, and the negative, the harm and diversity. And I show that just in the basis of those two problems, overall the desire for credit is positive. That is, the gain we get from the public goods problem sort of outweighs the harm that we lose from the loss of diversity. But that's just for two of those, right? I mean, there's a lot more, so that's hardly all the way. But that's, I think, an indication of kind of some of the next steps that a lot of us are interested in taking, is trying to combine these individual causal relations between the credit desire and these individual effects, and trying to develop a more holistic picture about how these things can be compared to one another. So while we've made a lot of progress, there's still a lot of questions that are left open. There's still a lot more to come. But what I hope that I have successfully convinced you of is that A, this is a philosophical problem that is important for us understanding both how science functions and how maybe it ought to function, and that it's a problem which is worthy of both the study that's been done, but also worthy of future study, and one that's really important, I think, for us as a field to take on if we really hope to understand how modern science both functions and also how it might be made better. Thank you.